Advanced Math, Set 108, Matrix Addition and Multiplication. So just as a reminder about matrices, a matrix is a rectangular array of numbers or symbols that represent numbers. So here are some examples of matrices. They basically are just an arrangement of numbers. They're shaped like a rectangle. They can have parentheses or brackets, or they don't necessarily have to have brackets or parentheses. So the individual symbols or numbers are called the entries or the elements. So in the first matrix, 4 is an element of that matrix. So the size of the matrix is defined by row and then column. So when we talk about the size of the first matrix, it has 2 rows and 2 columns. Again, rows go side to side, and so there are 2 rows, and then columns go up and down. So this one has 2 columns, so it's 2 by 2. The second one has 2 rows and 4 columns. The third one has 3 rows and 1 column, so it's a 3 by 1. The next one is also a 3 by 1 matrix. And the last one has 1 row and 4 columns, so it's a 1 by 4 matrix. So the order and the way that you name the matrix is important. The order matters. It's always row first, then column. Okay, so matrices can be added if they have the same order, which means they are the same size. They have to match up because you go entry by entry. So if I have matrix A and matrix B, they're both 2 by 3 matrices, so I can add them. And so what I want to do is I just want to match up the same elements in each matrix. So for the first entry, I'm going to have 4 plus 6. And then I'll go to the first row, second column in each matrix. That's going to be 2 and negative 3. And then 3 and 4. Then we'll go down to the second row, 1 plus 6, 0 plus 2, and 5 plus 0. And then this step here where I'm just showing what you're adding is not necessary. You can just do it in your head. So when we add A plus B, we get 10, negative 1, 7, 7, 2, 5 for A plus B. Matrix addition is commutative. So when we have A plus B, it is the same as B plus A. You always have to be careful because it's not everything that works in algebra is going to work with matrices, which we'll go into in just a few minutes. So matrices have an additive identity and a multiplicative identity. Just like the real numbers have an additive identity, meaning there's a number that when you always add that number to another number, you get the same number back. So in the real numbers, the additive identity is 0, because anytime we add 0 to a number, we're always going to get that number. So 0 is the additive identity. That's for real numbers. Now when we talk about matrices, in order to get the same matrix when you add, your additive identity is going to be a matrix full of zeros that's the same size as the matrix that you're adding to. So we can add the matrix of zeros first or second, doesn't matter, you're still going to get that original matrix when you're done. So a 0 matrix of the same order, meaning the same size, as the matrix being added is the additive identity for matrices. Okay, we're going to talk about the multiplicative identity in just a little bit. So a matrix can be multiplied by a single number. The single number is called a scalar. It's called scalar multiplication. Or it can be multiplied by another matrix, which gets a little bit more complex. So first of all, scalar multiplication is fairly simple. You have a number in front of the matrix, And it's just like the distributive property where you're going to distribute that number to each term. So negative 2 times the matrix shown is going to give you the result of negative 8, let's go rows. So negative 8, negative 2, negative 12, negative 10, or that should be positive 10, negative 4, and positive 4. Okay, if I have 3 times the matrix 1, 3, 6, 2, I get 3, 9, 18, and 6. Matrix multiplication is not commutative. In the real numbers, when we multiply two numbers, say 3 times 6, 3 times 6 is 18, and 6 times 3 is also 18. But when you multiply matrices, A times B does not equal B times A, which we'll go into in a few minutes. In order to multiply two matrices, now this is pretty key. In order to multiply two matrices, the number of columns in the first matrix must match the number of rows in the second matrix. So if I have a 3 by 2 and I'm multiplying it by a 2 by 2, the two numbers in the middle have to match. So the 2's match up. If I multiplied a 2 by 2 matrix by a 3 by 2 matrix, it's not going to work because they don't match up, so you can't multiply them. If you multiply the 3 by 2 by a 2 by 2, the answer is going to be a 3 by 2 matrix, and the way that you figure out the dimension of your result is those outside numbers. So 3 by 2 times a 2 by 2 is going to give you a 3 by 2 matrix. So if I multiply a 2 by 5 by a 5 by 3 matrix, I can do it because the inside numbers match, and the result is going to be a 2 by 3 matrix. The product matrix. The product is the matrix dimensions. Okay, so when you're multiplying, just like when you're identifying a matrix, you always do row and then column. So we're going to multiply these two matrices. I have a 3 by 2 matrix, and I'm multiplying it by a 2 by 2 matrix. The inside dimensions match, and my result is going to be a 3 by 2 matrix. So I know that much. Now I'm going to go by row and column. So what I'm going to do is I'm going to take the row of the first matrix and then multiply and add it to the column of the second matrix. So first row, first column is going to look like this. And so what I'm going to do is I'm going to take the first term and multiply it by the first term. So 1 times 7, and then the second term times the second term, so 2 times 9, and I'll add those together. So 1 times 7 plus 2 times 9, which is going to give me 7 plus 18, which is 25. Now the answer goes in the first row, first column of my answer matrix. So first row, first column is going to go right here. That's 25. So let's do another one. First row, second column. So first row, second column, I'm going to multiply 1 times 8 and add it to 2 times negative 2. So I get 8 plus negative 4. My answer is 4. And I'm going to put it in the first row, second column of my answer matrix. Okay, the order doesn't matter that you multiply. You can do it in any order. A lot of times it's just helpful to go in a systematic way. So now we're going to do second row, first column. So second row, first column is going to be the 3, 4, and the 7, 9. So 3 times 7 plus 4 times 9 gives me 21 plus 36, or 57, and the answer goes in the second row, first column. Third row, first column. Third row, first column, I'm going to do 5 times 7 plus 6 times 9. So I would get 35 plus 54, which is 89. The answer goes in the third row, first column. Okay, second row, second column. Second row, second column is going to be 3 times 8 plus 4 times negative 2. 24 plus negative 8 gives me 16, and it goes in the second row, second column. We have one final entry left, and that's going to be our third row, second column. Third row, second column, 5 times 8 plus 6 times negative 2 gives me 40 minus 12, which is 28, and that goes in the third row, second column. So that's matrix multiplication. It's a little bit tricky, kind of long. We'll do a few examples. So first of all, we're going to show that matrix multiplication is not commutative. So I'm going to take matrix A and multiply it by matrix B. And so we'll start out with the first row, first column. And so 4 times 1 plus 1 times 3. The second, let's see, we're on the first row, second column. So first row, second column, 4 times 2 plus 1 times 4. Then we'll do second row, first column, 3 times 1 and 2 times 3. And then second row, second column, 3 times 2 and 2 times 4. Okay, so the result is going to be 7, 12, 9, and 14. So A times B gives us 7, 12, 9, and 14. Now, if we do B times A, we'll start with the first row, first column. So 1 times 4 plus 2 times 3. So 4 plus 6. We'll do the first row, second column, which is going to be 1 times 1 plus 2 times 2. The second row, first column, 3 times 4 and 3 times 4. And second row, second column, 3 times 1 and 4 times 2. So 4 plus 6 is 10, 1 plus 4 is 5, 12 plus 12, and 3 plus 8. So my solution is 10, 5, 24, 11. So this shows that when we have matrix multiplication, it's not commutative because I took A times B, I got one solution. I did B times A, I got a completely different solution. Okay, so now we'll talk about the multiplicative identity. So when we're talking about real numbers, the multiplicative identity is what number you multiply by to always get the same number. So in the real numbers, multiplicative identity is 1. We can multiply by 1, and we'll always get the number that we started with. So for the matrix, you only have a multiplicative identity for a square matrix. And for square matrices, the multiplicative identity is a square matrix with a diagonal of 1s, and every other entry is 0. The diagonal goes from left to right, top to bottom. And so a 2 by 2 matrix looks like this. This is the identity matrix. A 3 by 3 looks like this. A 4 by 4 is going to look like this, and so on. So the product of the matrix and its identity is always going to be that matrix. So if I multiply 4, 1, 2, 3 by the identity matrix, I have first row, first column, 4 times 1 plus 1 times 0. And I do first row, second column, 4 times 0 plus 1 times 1. Second row, first column, 2 times 1 plus 3 times 0. And second row, second column is going to be 2 times 0 plus 3 times 1. So my result is going to be 4, 1, 2, 3, which is what I started with. It also works if you do it the other way around. So first row, first column is going to be 1 times 4 and 0 times 2. And then first row, second column, 1 times 1, 0 times 3. Second row, first column, 0 times 4, 1 times 2. And second row, second column, 0 times 1, 1 times 3. So again, 4, 1, 2, 3. So when you're multiplying by the identity matrix, the order doesn't matter. Okay, so now we'll just do a couple of examples of matrix addition and multiplication. So this first one is just matrix addition or subtraction. And so, again, all you have to do is match up the matching terms. So So 4 minus 3 gives me 1. 2 minus 5 is negative 3. Negative 2 minus negative 4 is going to be a positive 2. 6 minus 4, 3 minus negative 2, and 5 minus 6. Next example says multiply these two matrices. So the first thing you always do is check the dimensions. We have a 3 by 2 multiplied by a 2 by 2, so our result is going to be a 3 by 2 matrix. So we'll go first row, first column. So we have 2 times 1 plus negative 3 times 4. So 2 plus negative 12 is negative 10. Row 1, column 2 is going to be 2 times 2 plus negative 3 times negative 5. So we have 4 plus 15, which is 19. Row 2, column 1, 3 times 1 plus 4 times 1 gives us 7. Row 2, column 2 is going to be 3 times 2 and 1 times negative 5. So that gives me 1. Third row, first column, is going to be 4 times 1 and 5 times 4. So we get 4 plus 20, which is 24. And row 3, column 2, 4 times 2 plus 5 times negative 5. 8 plus negative 25 is negative 17. So now we just go and we put the answers in the correct corresponding answer places. So negative 10 goes in row 1, column 1. 19 goes in row 1, column 2. 7 in row 2, column 1. 1 in row 2, column 2. And so on and so on. So 24 and negative 17. And that's our solution. Okay, last example. Multiply these two matrices. Now this one's going to be nice because it has lots of zeros in it. So you always like to see zeros in matrices when you're multiplying them. It makes them a lot easier. So we have a 3 by 3 times a 3 by 3. So our solution is going to be a 3 by 3 matrix. And we'll just start row 1, column 1. So row 1 is 0, 1, and 2. And we're going to match it up with column 1, which is 1, negative 1, and 0. So we have 0 times 1, 1 times negative 1, and 2 times 0. So 0 minus 1 plus 0 gives us negative 1. Row 1, column 2, we have 0 times 0, 1 times 0, and 2 times 1. So the answer is 2. Row 1, column 3 is 0 times 1, 1 times negative 2, and 2 times 3. So we get 4. Row 2, column 1. Row 2, column 1. Negative 1 times 1 plus 0 times negative 1 plus negative 2 times 0. So we get negative 1. Row 2, column 2. Negative 1 times 0 plus 0 times 0 plus negative 2 times 1 gives us negative 2. Row 2, column 3 is negative 1 times 1, 0 times negative 2, and negative 2 times 3. So we get negative 7. And row 3, column 1. 3 times 1 plus 4 times negative 1 plus 0 times 0 is negative 1. Row 3, column 2. 0 times 3 plus 0 times 4 plus 0 times 1. So we get 0. And row 3, column 3. 3 times 1 plus 4 times negative 2 plus 0 times 3 gives us negative 5. The last step is to just put everything in its place. And you can do it as you go along too. So negative 1, 2, 4,